Welcome, 10th grade students in the Euclidean geometry course. Because you're hearing this message, you've been put into the Euclidean geometry class. There's two geometry classes this semester. One of them is for people who want to dig in a little bit deeper into geometry, and one is the standard geometry classes usually offered in high school. If you feel like you've been put in the wrong course, feel free to contact me about it. In this course, we're going to be doing geometry the way it's been taught for thousands of years. So, today we're going to be covering Euclidean geometry. So, who is Euclid and what is Euclidean geometry? Well, let's go way back. Euclid was a Greek mathematician and philosopher thousands of years ago. You may be more familiar with Plato. Plato is a good example of how Greek philosophers viewed reality. They viewed it a very different way than you and me. So we're used to calculators and other measuring devices. So if we saw a triangle and we wanted to find its area, what we'd probably do is we'd get out a ruler or a measuring app on the phone. We'd measure each one, and we'd find the area to some kind of decimal spot, and we'd feel good about it. That is not what Plato liked, not at all. So Plato's view of math was that all things were ideal. He had what was known as the Platonic solids, for instance. Platonic solids. These were perfect shapes. They were symmetric in every way. When Plato studies shapes and when he studies geometry, he conceives of things as perfect. So in geometry, in Euclidean geometry, all lines are infinite lines, all circles are perfectly round, all lines are straight, and so on. And they do things very different. You see, many of you have heard about the scientific revolution, basically, or the scientific method. So I want to see if you can remember the scientific method. Let's see if I can spell it right. What is the scientific method? Pause the video for a second and start to think about it. What is the scientific method in the scientific revolution? Okay, I'm pausing. The scientific method was an alternate way of thinking about the world. This is modern. It's good. In the scientific method, we use deductive reasoning. That's where we analyze the world and get results and get theories from that. What the ancient Greeks did in all other ways was using inductive reasoning. Start with what you think is true and come up with facts about the world. Okay, deductive reasoning has been great and is better for almost every science. I mean, the Greeks used to come up with ideas. They thought that women were failed attempts by the gods to create men, and that explained a lot of things about women. That's clearly not true. They thought that the body was controlled by 4 different fluids, which influence your emotions. The scientific reasoning, the scientific method, and the scientific revolution kind of overcame all of that. Okay. But one thing they did do good in was geometry. With geometry, we can start with things we think are true and come up with facts about the world. So what are you going to be doing in this course? Well, we're going to be going over Euclid's book. Euclid's book is thousands of years old, and it's in Greek. It's been translated into pretty much every language in the world. It was the main textbook used, like in George Washington's day, Abraham Lincoln's, pretty much all the way up until about the 1950s. Euclid was the go-to math book. So Euclid has 13 books. Now this may look intimidating, but we're going to go at a slow pace and we're going to help you guys understand. The left side is the original Greek. You don't need this, and some of the translations don't have it. Feel free to search online for a copy that's easy to understand. But I feel like this is one of the best. So what we do is have all these definitions. These seem like a lot, but these are things you guys know. Obtuse angles are bigger than 90 degrees. Acute angles are less than 90 degrees. Okay? So what he does is he comes up with all these definitions, and these are like toys in a toy box. And he comes up with all these ideas, and then the main meat of the class and the main meat of the book is these propositions. How can you make an equilateral triangle? Okay, now this is actually something fun. Remember how I said that the Greeks like to be precise and real and ideal and don't like to just guess on things? This will help you make a perfect, exact equilateral triangle that you can do on your own. You see, there's only two tools that the Greeks had available that let them do things perfectly. Those were a straight edge and a compass. Now, you're probably familiar with the term compass as referring to a piece of magnetized metal that points the direction north. A mathematical compass, though, is a pair of arms with a pencil in it. This is like right here. And you put a spike in the middle, and then you drag the thing around and it makes a perfect circle. A straight edge is just an unmarked ruler that is just a straight line that you can just draw on. The reason they didn't use rulers is because rulers aren't precise, and the Greeks wanted to be precise and perfect. So the straight edge and the compass were their main tools. These tools were also used to make perfectly straight designs for navigation. So in this first example, we're going to go over the first real lesson of the class. This is just a brief overview. What they're doing is they're showing you how to make a perfect equilateral triangle. Now you can mess around with this when you get this PDF, but I'll show you a website where you can go, scienceversusmagic.net/geo, where you can actually mess around with this. So you can click on a base point and draw any circle out of there. How far apart are these two dots? We don't know. See, we're not using scientific method where we measure and stuff like that. We're using Greek reasoning. So we're just going to assume these are just some distance apart. So we can make a circle any size we want. So if we make a circle over to here, perfect. So let's do that. If I can figure out how. Oh, right. Yeah, so you don't have to click exactly on the dot. And then we make another circle the other way. Okay. And then if we take this dot here, I claim that this gives us a perfect equilateral triangle. Now, why is that? I want you to stop the video and think about that for a little bit. Okay, if you've come back, I'm not going to tell you the answer of why it's equilateral, but I want you to know this is perfectly, exactly the same length in every direction. And if you make this shape with a straight edge and a compass, you could actually test that for yourself. So I want you to think about why, and if you can come up with why, let me know. This is what the entire class is going to be, where I'm going to give you propositions. The answers are right here, but as you can see, they're a little hard to understand. Your goal will be to come up with an answer that you can understand, to explain to me why this is an equilateral triangle. So you have the book, but understanding the book is difficult. So here's the thing. This class, you'll have all the answers all the time. The challenge will be giving the answers in your own words to understand it completely enough. And so we're going to have a lot of different propositions. Now you may be thinking that the other class is probably going to be easier, but we're actually doing the exact same things in the other class, except instead of proving how to do it, we're going to just tell them what the answers are. So for instance, in book 4, we're going to do similar triangles. Here we're going to do circular tangents. This is all stuff that we're going to be doing in the other class as well. So in a way, this class isn't necessarily harder, it's just a different way of thinking of things. By the time we get to the very end of the class, we're going to get to very cool stuff. We're skipping a few chapters in the middle that aren't important. It's stuff from back before people had calculators, and there's a mess. In the last little parts, we'll learn how to even do 3D figures. So anyway, take a look, poke around here, try and see what this is, and hopefully we'll come to understand what is Euclidean geometry and what is this class. Tests will basically be me giving you a few propositions and seeing how you can prove them on your own. I may be willing to make them take-home tests, but this course is going to be adapted based on you, the students. If everyone in the class is struggling, we slow down or make it easier. If everyone's understanding, we keep going. If some people are doing better than others, we can give additional work for those who want more work to dig in deeper and learn more. This class is for you, it's designed for you, and I'm excited to have you here. Thank you.